Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, this is Waheed Ali from Government Boys Degree College, Goth. Today we are going to discuss a new topic, that is nomenclature of coordination compounds. Before starting this topic or coming to the main rules of the nomenclature of the coordination compound, we have to discuss few basic terms which are necessary in order to understand the nomenclature of coordination compounds properly. So first, what do you mean by the coordination compound or complex? It is defined by three ways. Number one, it is a combination of a simple cation and a complex anion. Means when a simple cation and complex anion are combined, then a complex is formed. Or another definition is, it is a combination of the complex cation and a simple anion. Or it is a combination of a complex cation and a complex anion. This is the definition of coordination compound. Now we have to differentiate between the simple cation and complex cation, or simple anion and complex anion. So the definition of simple cation or simple anion is that it is an atom or group of atoms which possess positive or negative charge respectively. For example, elements of the group first A like lithium, sodium, potassium, rubidium, cesium, or elements of group second A like calcium, magnesium, barium, strontium, they form a cations, and these are said to be the simple cations. While as the elements which belongs to the P block like fluorine, chlorine, bromine, oxygen, nitrogen, they carry the negative charge, and such ions which are found by these elements are said to be the simple anion like chloride, bromide, iodide, like oxide, like nitride, etc. Now what is a complex cation? Actually, complex cation is a positive ion, because cation word is used for a positive ion. So complex cation is a positive ion which is consist of a central metal atom, that is usually a transition metal or ion, and ligands. Now we will discuss later that what do you mean by the central metal atom and what is the ligand, but at this stage, when a central metal atom and ligands are combined together and carry a positive charge, then such a cation is said to be a complex cation. Now complex anion, it is again similarly a negative ion which is consist of central metal atom or ion and ligands. Coordination sphere, it is a square bracket in which a complex or coordination compound is written. That square bracket is said to be coordination sphere. This is the square bracket. Coordination number. Now coordination number means the number of the ligands attached to central metal atom or ion in a complex. If for example 2 ligands are attached to the central metal atom, then the coordination number of the complex will be 2. If 3 ligands are attached with the central metal atom, then the coordination number of the complex will be 3. A note is written at the end that a complex may be neutral, may be cationic, means having a positive charge, or may be anionic, having a negative charge. Neutral complex will be that in which there will be the zero charge on the coordination sphere, and you will observe that nothing will be written from the left hand side and right hand side of the square bracket. Such complexes are neutral complexes. Then cationic complexes will be those in which the positive charge must be present on the complex, and after that at the right hand side there should be a negative ion. They are said to be the cationic complexes. And the final one is the anionic complex, in which first a positive ion is written, a simple cation, and then a complex having a negative charge. So if a complex carries the negative charge, then such a complex will be anionic complex. Now let us discuss what do you mean by the central metal atom or ion. Central metal atom or ion means an atom or ion which can accept a pair of electrons from ligands, and any species which has capability to accept the pair of electron according to Lewis acid-base theory concept, it is known as Lewis acid. Actually, transition metals, central metal atom or ion are the transition metals. They are like copper, silver, gold, zinc, platinum, osmium, etc. These elements behave as a central metal atom because they have d orbitals in their valence shell or penultimate shell sometime, and they have capability to accept the pair of electron from the other molecules or the groups. They are known as ligands. Such atoms are considered as the central metal atom or ion. Names of central metal atom. Now, how can we write the name of a central metal atom regarding the nomenclature? In this case, we have distributed the complex into two categories. One is the positive complex plus neutral complex. In this case, if a complex is either positive or neutral, in both the cases, we will write the name of the central metal atom in English language followed by the oxidation state written in parentheses after the name of the central metal atom. For example, if we have copper, then we will write the name copper, and after the copper we will write 2 in numerals in parentheses. If, for example, we have to write platinum metal and its oxidation state is 4, then we will write the word platinum, and after the platinum in parentheses or small bracket we will write 4 but in Roman numeral. For example, if nickel is present in any complex and its oxidation state is 0, then we will write 0 at the end after the name of the nickel in the parentheses or small bracket. Another category is the negative complex. In the case of negative complex, we will write the name of central metal atom preferably in Latin, because some metals possess Latin names and English as well, while some of the metal are those which only possess the English name. So if we will look at the metal, if it has a Latin name, then we will prefer its Latin name. If it don't have, then we will write the English name. And then in the end we will add a suffix at the name of the metal, that will be ATE. Finally, again we will write the oxidation state in the Roman numeral in parentheses as we discussed in the positive and neutral complex. For example, Cu, name of this Cu in English is copper, but its Latin name is cuprum. Now Um is its prefix. Now we will replace this Um by ATE. The name will be cuprate. For example, argentum. And now Ag is the symbol of the silver. Silver is the English name, but its Latin name is argentum. Now is the suffix. We will replace the suffix by ATE and the name will be argentate. But for example, Ni, that is nickel, it is only English name, no any Latin name. That's why we will keep the name same and we will add ATE at the end. That is nickel. So after adding ATE, it will. Now come to the ligands. Ligands are actually, we can define ligand as an atom or ion or a molecule which is capable of donating electron pair or electron pairs to the central metal atom or ion. And according to Lewis acid-base theory concept, it is the definition of a Lewis base. Types of ligands. On the basis of charge, ligands are of two types: neutral ligands and negative ligands. Neutral ligand means having no charge, and negative ligands means having a negative charge. Based on the nature, ligands may be organic, means hydrocarbons are their derivatives, and inorganic means they will not be organic in nature. But if you want to go in detail about the organic and inorganic, go to the differences between organic and inorganic chemistry and the textbook. Now, how can we write the names of the ligand? First one, if the ligand is negative, then its name end in O. For example, Cn negative, it is a cyanide ion. But when we will write its name as a ligand, then it will be written as cyano. NO3 is nitrate ion. But when we will write its name as a ligand, it will be written as nitrate 2. SO4 negative is a sulfate ion, but when we will write it as a ligand, its name will be sulfate 2, etc. In the case of neutral ligands, name will be written as usual, as the name of the compound is in normal way, except the two compound. One is a water. We will not write the word water, but rather we will write the aqua. And and next one is NH3, that is said to be ammonia, but in writing it as a ligand we will write it as amine, not as a amine, ammonia. If we will write or mention the number of the complexes, then category A is that if there are more than one ligands but they all are same, then we will observe that whether the ligand is organic or inorganic. If the ligand is inorganic, then we will mention its number by using certain prefixes like di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, etc. But if the ligands are organic, then instead of these prefixes we will use word bis for 2, tris for 3, tetrakis for 4, pentakis for 5. Now these are prefixes which will be placed before the name of a ligand to mention its number, that how many ligands are present. For example, if there are 2 water molecules present in a ligand in a complex, then we will write di-aqu. If there are more than one ligands and they are different, then their names will be written in alphabetical order as per nature along with their prefixes. Now names will be written separately in alphabetical order, but each ligand will carry its own prefix. If it is inorganic, then the prefix will be used accordingly. If it is organic, then the prefix will be used accordingly. So IUPAC or IUPAC rules of the coordination compound, that is International Union of Pure and Applied Chemistry rules. The rule number 1 is that cation is named first, then anion, means first you will write the name of cation and then that of the anion, means negative ion. Ligands are always written first and then the name of central metal atom or ion is written. Ligands are named in alphabetical order. If they are more than one, if they are different, then their name must be written in alphabetical order. Now naming order of neutral complex means such a complex in which the net charge is equal to 0. In this case, first we will write the number and the name of the ligand, then we will write the name of the central metal atom or ion, and finally in the parenthesis we will write its oxidation number in Roman numeral. Naming order of cationic or positive complexes. This will be such a complex which will carry a positive charge. That's why I have written in square bracket a positive complex. In such a complex, it is necessary that there must be a negative ion written at the right hand side of the square bracket. In this case, the order will be number and the name of the ligands plus name of the central metal atom or ion, and after that having the oxidation number in the Roman numeral will be written in parentheses. Up to this one, this is exactly same as it was a neutral complex, but after that, as a negative ion is present in a cationic complex, that's why finally the name of the simple anion or negative ion will be written. Now finally the naming order of the anionic complex. Anionic complex are those which carry the negative charge. You will observe here that there is a negative charge complex written in square bracket. It is necessary to neutralize this negative complex that there must be a positive ion at the left hand side of the complex, because positive ions are always written first, then the negative ion. That's why first there will be a positive ion and then there will be a negative complex. The naming order will be, first we will write the name of the simple cation which is present before the square bracket, then we will go into the square bracket and we will write the name and number of the ligands. After that we will write the name of central metal atom or ion, and finally we will write its oxidation state or oxidation state of the central metal atom in the Roman numbers. Now these are few examples. The first example is CO small bracket NH3 small bracket over 3 and then Cl3 bracket over. Actually this is a neutral complex. You will look at there is nothing at the left or right hand side of the complex, so the net charge on this complex should be 0. The charge on the chlorine as a negative one will be -1, so -1 multiplied by 3 will be -3. Ammonia possesses 0 charge, and for the complex to be neutral, -3 charge on the 3 chloride ion must be equal to the +3 charge present on the let me show you the pointer on the +3 on the cobalt. So first here we will write the names of the ligands triamine trichloro, because there are 3 amines and the 3 chloro. Now thing is that both contain T in a front, but what we have written the name of the triamine first, because amine contain A as the first letter, while as chloro contains C as the first letter. That's why triamine will be written first in alphabetical order, while as next will be the trichloro. So first we have written the names of the ligands and then the name of central metal element, that is cobalt. As we discussed previously, that when a complex is neutral, then the name of the metal will be written in English, and finally oxidation state will be mentioned in the small bracket. That is the 3. Another complex, now you will look at, there is a square bracket, and after the square bracket there is something written, that is Cl. Generally chlorine is halogen having high electronegativity, it must possess a positive negative charge. Second thing is that always cations are written first and then anion. It means this complex is cation and this Cl here will be the anion. So first we will write the name according to the order as we discussed previously. We will write name of the complex first and then the negative ion. So coming to the complex, first we will write the names of the ligands. For example, there is penta-acco, chloro. Now people may be confused here that penta-acco contain P as the first letter, then I have written the chloro, C as the first letter, so C comes before the P. Actually alphabetical order is maintained on the basis of the actual name of the ligand, not on the number of the ligand. That's why acco contain A as the first letter, that's why I have written first acco, so penta-acco. Then there is single chlorine, that is chloro, and finally chromium, the oxidation state of the chromium here is 3, I have written it, and finally Cl is present in the negative ion, so it is chloride. Next one is AgNH3 and finally Cl. Again this is a positive complex, so in this case the name will be diamine silver 1 chloride. Next one is negative complex. Why it is negative complex? Because before the square bracket there is something written. It means that must be positive charge. According to the rules, positive charge is written first and then complex should be negative. So first I will write the name of this simple cation, that is potassium. Now it is not necessary to mention the number of the simple cation, because when you will balance the oxidation states, number will actually be placed, already be placed. So potassium, then we will come to the ligand, they are hexa, and cyanide is known as cyano, so hexacyano. Then finally there is iron. As you know, in the case of the negative complexes, if we have iron, its Latin name is ferrum, then Um can be replaced by Ate, so the Latin name will be preferred and it will be hexacyanoferrate. Oxidation state of iron here is 2, that's why I have written 2 in the small bracket. Then finally there is a compound, its name is tetraamine copper 2 sulfate, so it's a positive complex. If you want to go for the further exercise, then please you can check in your textbook and then you can apply further these rules that I have given.